We're beginning now with problem 12.8, and it's useful for companies to know who their customers are and how they became customers. And in this study of credit card use, a random sample of cardholders who applied for the credit card and a random sample of credit card holders who were contacted by telemarketers or by mail were drawn. And the numbers you see under column A and B were the total purchases made by each last month. And the question we're trying to answer is, can we conclude from these data that differences exist on average between the two types of companies? So, what we're going to do here is first calculate the average, the mean, same thing, average. So double click here, and for x bar sub 1 for the applied, the people who applied, and we can go up and close parenthesis, and we'll see that it was 130.925. In terms of the other column, the contacted, again the average, I'm going to click here. If I hold down my shift key and go end down, it automatically goes to the bottom, and we see that that range is B2 to B101. And the average for that column is 126.13. Now N1 and N2, we know they're both 100. If I didn't know that, I could use the count function, but in this case I do know it, so I'm just going to enter 100 for both of those. And now we need to calculate the variance for each. So again, it's a variance of a sample, so equal to start the equation, VAR, and here it is. No, that one, second one. Estimates variance based on a sample. So again, it's A2 colon A101 for 1023.359. And let's do the same thing for the contacted in column B. That's B2 colon B101 for 675 and 0.8545. Now, for some reason we wanted the standard deviation. We also could do that. I don't know that we really need it in this case, but the square root, SQRT, and then inside the parentheses, just select that cell, which gives us 31.9888. And again, I can just drag the fill handle, and now look in there, up, and it automatically copies it down. So we're good. And now for the f-test, variance 1 divided by variance 2. So equal, and then cell E13 divided by E14 gives us 1.51471. So now that we have that f calculated, what we need to calculate is the rejection range with the f. So it's going to be the 0.025, and because both samples are 100, the degrees of freedom for each is going to be 99. So again, equal f, and so we enter the probability 0.025, comma, for the next parameter, which is degrees of freedom for the applied versus the degrees of freedom for the contacted credit card holder, and then hit enter, and we see that it's 0.672842. Let's do the same thing for this one, except for it's going to be 1 minus 0.025 to give us the upper number on that rejection range, excuse me, and 99 and 99 for 1.486. So, given that this F-test reveals sufficient information, evidence, because the 1.514171 is greater than the 1.486, to infer that the variances differ, and therefore we should use the unequal variances test and estimator. Again, because the rejection range would be anything less than this 0.672842 or anything greater than the 1.486234, and the 1.514171 is greater, therefore we need to use the unequal variance test. And we get this fun formula right here, which I'm going to break down into 3 parts just to make it easier to do the calculation. So, let's start right here with the numerator. So it's equal to, and it's going to be the variance divided by n1 plus variance 2 divided by n2, and we're going to square that whole amount. So that's the little caret above the 6 character. I hit the shift and the 6 key, and then the 2 to square it, and hit enter, and it gives us 288.7328. And now let's do the first part of the denominator. So again, it's going to be this number right here is the first part, and then this part right here, the second part. So it's going to be equal to this variance divided by n1, and I'm going to square that, and then I'm going to divide the whole thing by n1 minus 1, which gives us 1.057843. For the second part of it, it's going to be equal to variance 2 divided by n2. I'm going to square that whole amount, and then divide by n2 minus 1, which gives us 0.461393. So now to actually calculate the V, we're going to go the numerator divided by the denominator, which is going to be the first part of it plus the second part of the denominator, and that gives us degrees of freedom, the V, of 190. And for this T, then we're going to go equal T, and we're going to do the inverse there. So we put in the probability, which is the 0.025, with the degrees of freedom of 190, which gives us minus 1973. And you can also look that up on page 311. I believe that should say 190 rather than 90. Let's do it again for the second T. So the probability, in this case 1 minus 0.025, and then the degrees of freedom 190, and that gives us 1.973. So once we know that, we can go ahead and calculate. So we've got the rejection reason here, and now we're going to calculate the numerator and the denominator for the t statistic, and then come up with the actual number there. So again, equals, and let me just, it doesn't like that. We'll go up here, x bar 1 minus x bar 2, and then minus the mu, which is actually going to be equal to, we're going to call that 0. So the numerator is 4.7896, and then for the denominator it's going to be equal to the square root of variance 1 divided by n1 plus variance 2 divided by n2, and we go back and close the parenthesis, and that gives us 4.122152. So to get the t for this case, it's simply taking the numerator divided by the denominator, which gives us 1.16. And since 1.16 is not in that rejection region, the rejection would be greater than 1.973, we would say that there is not enough evidence to infer that differences exist between the two types of customers, those who applied versus those who were contacted. Alright, that's it for 12.8.